When it comes to electroluminescence imaging, PV cells and modules need to be supplied with a reverse current so that they emit near-infrared light, which is then captured using a special camera. In addition, the surrounding environment needs to be dark. For this reason, electroluminescence inspections are ideally carried out at night, because daylight contains a large amount of near-infrared radiation, which is much stronger than the near-infrared light emitted by the PV modules themselves. If an electroluminescence inspection must be performed during the daytime, a dark environment, such as a temporary enclosure or a darkroom, has to be set up around the PV modules being inspected. Similar to infrared inspections, the use of unmanned aerial vehicles, or drones, is attractive because they can quickly cover large inspection areas. From a practical standpoint, recording electroluminescence imagery as a video is often the most convenient option, given the high number of frames per second required and the limitations of the available hardware. However, there are several challenges that currently prevent the widespread adoption of drone-based electroluminescence inspections. The first major challenge is related to operating conditions. As mentioned earlier, electroluminescence inspections are best performed at night, but flying drones at night significantly increases operational difficulty and the risk of losing control of the unmanned aerial vehicles. Although techniques for daylight electroluminescence drone inspections have been proposed, in these cases drone stability becomes extremely critical, and wind conditions must be very favorable. The second challenge is related to powering the PV modules. For electroluminescence inspection, the PV module strings must be energized, meaning they need to be connected to a DC power supply to inject current into the cells. This process requires considerably more effort than infrared inspections. In cases where the module strings are connected to DC combiner boxes that are spread across the site, the DC power supply has to be moved from one box to another during nighttime operations, which adds further complexity. These requirements make the unmanned aerial vehicles-based electroluminescence inspection approach less efficient overall. The third difficulty concerns camera capabilities. Most commercially available cameras that use silicon sensors have limited sensitivity in the near-infrared wavelength range. As a result, relatively long exposure times are required, ranging from a few seconds to several minutes. Such long exposure times can easily lead to blurred images when the camera is mounted on unmanned aerial vehicles. At present, there are still no turnkey solutions available on the market for performing electroluminescence inspections using drones, and wireless communication and remote camera control remain some of the biggest technical challenges.